Technology is always advancing. If you keep regressing, it won't be long before we're back to the era of wearing animal skins and eating raw meat. If we went back to the Stone Age, what would you wish for? Don't even mention buying lottery tickets. That's absolutely impossible. Short axle repair is practically a staple in Pakistani repair videos. Whether it's axles or gear shafts, to be honest, we've seen quite a few repairs after they've been shortened. However, while the length of this one is quite average, the diameter is definitely sufficient. As for how it broke, that's not really important. What's important is that they recently developed a new method for repairing broken shafts, which is very different from the previous methods. It significantly improves in terms of stability and strength. Today we'll watch these videos to see how this newly developed broken shaft repair method is performed. All right, everyone, something feels off. Why is there so much gesturing and then a different person performing the operation? Is this a newly hired technician? Wait, is it possible that today's broken shaft repair is this technician's entrance exam? If the connection goes smoothly this week with reliable strength and the method is unique and ingenious, I might just pass the test. I'm just kidding, but it's possible. Otherwise, how would you explain it? After gesturing for a while, they change the operator, right? The first step is to remove the longer, larger fracture surface. Then start drilling a center hole, enlarging the drill bit diameter to increase the inner hole diameter. This is a standard jointing procedure. You can't skip this step without drilling a hole in the middle for effective connection, right? Okay, now the hole is drilled. Next, we're marking the inner hole with a marker. That means we'll be doing the threading. So far, this is the same procedure we often see in Pakistani shaft repair videos, since threading is a relatively reliable repair method. So no matter how unconventional it is, this is still very commendable. Some viewers watching videos of shaft repair might wonder, are Pakistani shafts really that easy to break? Actually, Pakistan really does experience a lot of axle breakage, especially on trucks' front axles. Why? Because as you all know, their trucks are mostly second-hand Japanese trucks. And Japanese trucks, especially Japanese vans, really don't have a very high load-bearing capacity. Using Japanese trucks with Chinese loading methods, tell me, with broken axles, where can they go? Right? Okay, let's get back to the video. Next, we'll be machining the core for the inlay. The core is still being machined using a marker-held thread milling cutter. And you know what? The threading is actually pretty good, and I think the tool holder is also very well ground. Let's look at the machining details. The threading is indeed very good. Why do I say that? Don't expect their thread milling cutters to be high-end. They're basically all homemade and hand-ground. Next, we'll insert this core into the center hole of the broken pin. Is the thread on the threaded machine correct? Okay. Next up is a positioning welding operation. Welding, well, you can't avoid it. But watching too much can hurt your eyes. So, using a screen protector is definitely worth a shout-out. Some friends might ask, how can watching welding on a phone hurt your eyes? It doesn't hurt your eyes, but many of you have probably seen a special effect called a flash, right? While it's not as bright, the effect is almost the same. So it's still advisable to use a screen protector. Okay, next, we'll move to another lathe with a 3-jaw chuck. We'll prepare a round iron disc and use a center turn, along with a cutting tool to drill a round hole in the center of the disc. Then we'll perform a surface machining operation. Next, we'll insert the machined round iron disc directly into the center position we just machined. Then, we'll use electric welding again to weld it in, this time for positioning welding. The main purpose of this section of the iron disc is, of course, to compensate for the broken disc and the missing length of the machined surface. I think everyone can understand the principle now. Then, we'll carve a dent into the iron disc. This is what makes today's process unique. Moving on, we're now at the boring machine in the shop. Next, we'll drill 3 holes in the dented area of the iron disc. Can you guess how ingenious and technologically advanced this is? If not, don't worry, we'll show you shortly. The next step, of course, is to process the section with the smaller fracture. The processing method is similar to other parts, so we don't need to go into too much detail. However, this side doesn't need threading for embedding. A central hole can be machined directly. In the blink of an eye, the fracture surface and the central hole are all machined. Next comes the crucial step. Remember the 3 small holes we machined earlier? Place a steel ball in each of these 3 holes, roughly adjust the mating positions, and then you can start hammering with force. Of course, this hammering doesn't directly connect the parts. Can you imagine what will happen after hammering? It's done. It's hammered in and can't be pulled out. Even without me saying to strike hard, 3 indentations will definitely remain on the flat surface of the broken tactile bun. These are the relative positions of the 3 holes on the broken tactile head of the bun, absolutely correct. Next, use a brick to drill holes in the indentations. The holes will be perfectly aligned. See, there's nothing wrong with that, right? Now there are small holes on both sides of the broken surface. Then, find 3 small iron rods of suitable diameter and insert them directly into the holes. Next, the 2 sides are joined together. These 3 iron rods provide support and fixation, offering significantly greater strength than ordinary threaded inlay methods. Another point is the iron disc added in the center earlier. It also serves a purpose. As you can see, the diameter of this disc is not easily felt. During the welding process, it acts as a bevel. However, by using a lathe tool to create a deeper indentation in the inlaid iron disc before welding, the strength is even better. The next step was relatively simple: to perform a firm welding operation on the broken area. The welding point was the area where the added iron disc had been placed, with a recessed bevel. The iron disc's hardness was clearly less than that of the 2 shafts, so the depth of the weld pool was very deep. It must be said that the experienced welder or the job applicant was quite skilled in welding. After the welding was completed, the next step, of course, was surface finishing. To be honest, compared to all the other methods they've used to repair broken scrolls, I feel this method offers better relative strength. What do you guys think? Is it really usable?